Welcome back. This is the third lesson recording for IM2, May 17th, 2021. So where we stopped was that looking at this rectangular prism, you have two opposite sides. Okay, so as bases, I could have picked any two opposite sides. I picked 2 inches by 5 inches. Okay, but you could have picked 4 inches by 5 inches, or you could have picked 4 inches by 2 inches as well. I just picked 2 inches by 5 inches, the top face and the bottom face as the base. That means the other sides are this panel on the right, the back, left, and the front, right? So we have rectangular prism, so we have 4 faces. Opposite faces are the same size. So you can tell that the one at the back and the one at the front will be exactly identical. The one on the side here, left, and one on the right here will be exactly the same, okay? And to find the surface area is 2 times base area, okay? So the top and the bottom surface, and then 2 side panels, so the left and the right, and then the front and back panel. Okay, so if I was to use all these dimensions, I know that this, we were told is 4 inches. I know that this length is same as this length, is same as this length, is same as this. This 5 inches, the red line, is going to be, if this is 5 inches, this is also going to be 5 inches, 5 inches, and 5 inches. And likewise, 2 inches here, 2 inches here, 2 inches here, and 2 inches here. So you need to pull apart each of the rectangles. Okay, so for the 2 base area, that's 2 times 5. 2 times 5 will be 1 area, 1 base, and we need to multiply by 2. What about the 2 side panels? That's this panel here and this panel here. Okay, so that's going to be, height is going to be 4 and base is going to be 2. So 2 times 4 is 8. And then we need to multiply that by 2 because there are 2 of them. And then the front and back panel, that's going to be 4 times 5. And there are 2 of them, so multiply that by 2. And that ends up with 552 inches squared. What about the last one? Finding the surface area of this. What shape is this? The base is pentagon, okay, and it is all the faces are meeting at a vertex or apex. So it's a pyramid. It's a pentagonal pyramid. So surface area is going to be the area of the base, which is a pentagon, and we have 5 isosceles triangles. Okay, they are all going to be identical because we know that we are told that this is a regular pentagon. You can tell by these notch marks, right? So it's a regular pentagon. That means each of the isosceles triangle is going to have the same measurement. The faces are going to be the same. So what is the area of the pentagon? Well, we're given this, the side length only. Side length, oh no, actually we're given the side length of 8.1. We're also given the apothem length, which is 4.1. That makes our math much easier, doesn't it? Okay, area of the pentagon is going to be 5, because we're going to create 5 of those little triangles. 5 times half times 6 times 4.1. 6 times 4.1. Oh, 6 is the side length here. I'm sorry. This 8.1 is the slant height. Okay, 6 times 4.1, and that's the area of the pentagon. Then multiply that by what is the area of each of the isosceles triangle. The base of this triangle is going to be the side, which is 6 times 8.1 times half. And that's going to be one triangle, and we have 5 of those identical triangles. And that leaves me with 61.5 plus 121.5, which is 183 meters squared. Now going back to our slides. So we've just figured out how to calculate the surface area of the pentagonal pyramid, rectangular prism, hexagonal prism, and rectangular pyramid. We know how to do prism and pyramids. Do we know how to do this regular dodecahedron? Well, we know how to calculate the area of a pentagon, and there will be just 12 of those surfaces. We know how to do that, okay? The elliptical cylinder, you're going to learn to do that in IM4 when you learn conics and figuring out the area of the elliptical cylinder. And the torus you will learn in calculus. That's pretty exciting. Okay, so for now we're going to be working on cylinder, surface area of a cylinder. So if you have a cylinder, you have to just picture a can. Okay, so a can is with a radius of r and height of h. Okay, so picture a can. It's going to look like this. And if you opened it up, it's going to you're going to form a rectangle and two top and bottom bases, right? So the surface area of a cylinder is going to be made up by 2 times pi r squared. That's the top circle and the bottom circle. Pi r squared is the area of the green circle, right? And there are 2 of them, so we're multiplying it by 2. And 2 times pi r multiplied by h. Where does this come from? It is the area of this rectangle. Okay, so what is the width of, or the width is h, length of this rectangle is going to be 2 pi r, because that's length is going to wrap around the outside length of the circle. What is the outside length of the circle? That's a circumference. And we know the circumference formula is 2 times pi times r. So the length is going to be 2 times pi times r, and h is going to be the height of this rectangle. So that's where you get 2 pi r times h. Make sure you understand the formula. Don't just copy it down and use it. So width of the rectangle is the circumference of the circle. What about cone? Cone, surface area of the cone is given by this formula pi r squared plus pi rs, where surface r is the radius, s is the slant height. It's not the perpendicular height from the center to the apex, but it's the slant height. It's from the edge of the circle to the apex. Okay, so slant height is going to be this. Okay, and where does this formula come from? Maybe we'll be able to have some time to go through that, but for now I just want you to copy down this formula and use it. How do I use it? So if I have this cone, okay, if I was trying to find the surface area is pi r squared plus pi rs. So S is the slant height. Slant height is the 13 inches. Try to picture this, even though it looks like just a flat image. Try to picture it as a 3D image. That's why the circle is not perfect circle, but it's sort of more of an oval to indicate this is a 3D image. And 13 is the slant height. And so radius is 5 and slant height is 13. So you just plug it in to the equation and you get pi times 5 squared, because 5 is the radius, plus pi times 5 times 13. And that's going to be 25 pi plus 65 pi, which is 90 pi inches squared to be exact. All right, so now you're going to be working on the more practice problems, and you're going to, if you have a printer, you're going to print this out. You're given 20 minutes, and you're going to submit it at the end. Ask me if you have any questions about it. Here's the review of the answers. Okay, so first question, you are given the radius is 6 inches and the height of the can is 10 miles. Okay, 6 miles and 10 miles. So radius is 6, height is 10. So put that into the formula. 2 times pi times r squared. R is 6. So it's going to be 2 times pi times 6 squared. 2 times pi times r times h is 2 times pi times radius times 10. That becomes 72 pi plus 120 pi, which is 192 pi miles squared. Number 2. Okay, so now the can is on the side, but you can still tell which is radius, which is the height of the can. All right, so in this case, radius is 1 centimeters, height is 3 centimeters. So again, you use the formula and you get the answer to be 8 pi centimeters squared. And number 3, you're going to use the formula surface area of a cone is pi r squared plus pi times r times s, where s is the slant height. So that's going to be 8.9 meters is the slant height, radius is 4. So you can picture this as a sector of a cone or sector of a circle, okay, and multiply by, and base is a circle as well. Okay, so surface area is pi times r squared, which is 4 squared, plus pi times 4 times 8, 9. 4 is the radius of the circle again, times 8.9. And that leaves us with 51.6 pi meters squared. Going back to the slide, where did the formula come from? Surface area of a cone is pi r squared plus pi r s. Okay, well, we know that it is surface area is going to be made up by the base circle and a portion of a circle. Okay, and it's actually a sector, right? With s being the slant height. So sector area is a fraction of the circle area with radius s. Okay, so s is the radius of this blue circle. And fraction we're dealing with is what is the circumference portion of the whole circle. Well, the circumference length is going to be the blue arc length of the portion we're dealing with is blue arc length. This length divided by the blue circumference, the whole circle, right? And that is, this arc length is going to be, because it's wrapping up exactly around the circle. So arc length, this arc length, the length of that is going to be the circumference of this circle, the orange circle, and that is going to be pi r, 2 pi r. And the blue circle circumference is 2 pi s, because the radius of this blue circle is s. And then the sector area is fraction of the blue circle area, and this fraction is 2 pi r divided by 2 pi s is really going to be same as r over s multiplied by blue circle area. This blue circle area, if I was to imagine the whole circle, is going to be pi s squared, because r, radius in this case, is s. So that this simplifies to r over s. Pi s squared is pi times s divided by 1. And the s and s cancels out, and you are left with pi times r times pi times s, which pi r s. All right, so closing. You are going to enter on the table of content what we did today. We did surface area of prism, pyramid, cylinder, and cone, and you are going to be submitting both your work as classwork 517. Thank you for listening.